Oh, hello everybody. My name is Petr Zemek and welcome to a pre-recording of my talk entitled Pull Requests, Code Reviews and High Quality Code. It is a talk that I'm having on the 28th of April 2020 at the Brno University of Technology, Faculty of Information Technology. Once upon a time, there were two workflows. The first of them I like to call the lone wolf workflow, and it works like this. Basically, you put all your changes directly into master. So bug fixes, new features, refactorings, pretty much everything. So you code it, commit it, push it, and you're done. So this was the first step, and there is no step two. So basically you repeat this over and over until you are done. This workflow is very popular among students or sole developers who do not work in a team, or for smaller open source projects. There is a second workflow which is more cautious and which I would like to advocate in this talk. And this workflow is composed of the following steps. So first, you create a new branch from the current master. Then you implement the needed change there. So it can be a bug fix, new feature, improvement, whatever you need. Then you push the branch and create a so-called pull request from it. A pull request is basically a request to review your code and merge it to, for example, master. So after you create a pull request, it's going to go through a process called a code review, when someone takes a look at your code and decides whether it is good enough and can be merged, or whether you need to do some additional changes or fixes. And after the pull request is approved, the branch is merged into master. And you can continue this cycle. So you'll create another branch, implement the needed functionality there, create a pull request, it will be reviewed, and then either approved or disapproved. So let's take a look at a pull request. What is a pull request? It's basically a request to review your changes and merge them, usually to master. When people hear the term pull request, it's most commonly associated with pull requests on GitHub. Here we can see such a pull request. I have opened it in a browser. So this is the GitHub's interface. First of all, each pull request has a title. So in this case, that's one of mine pull requests entitled Parallelize Compilation of Yara Rules During Installation. Here you can see that the pull request was merged by Petr Matula. This was the name of the branch that was merged. Here you can see the timeline and comments. First comment is always the description of the pull request, in which you state what the pull request does, how you have implemented it, and other additional details that may be needed. For example, here I have written what it does, some measurements, some remarks, and that it implements ticket number 540. Here we can see that the reviewer has approved the pull request. It was assigned to the same person who reviewed it, and that person was responsible for merging the pull request. We can also set some labels on GitHub, but that's irrelevant. So basically, that's a pull request. It should be noted that some systems, especially GitLab, calls pull requests merge requests. The term pull request has a historical origin. It originated from the git request pull command, which in the dark times you used to create pull requests manually and sending them to people who will then pull your changes into their repository. You cannot just merge them if the changes are on a different repository, but you can use git pull to get the changes from another repository into your repository and get them there, which is why it is called a pull request. But anyway, at the end, you always merge the pull request, so even the term merge request is correct, and it depends on the people who are you talking to or on the system which you are using. So bear that in mind. If you see the term merge request, it has the same meaning as a pull request. So now that we have seen what is a pull request, let's take a look at code reviews. Code review is a process of looking at another person's code and checking whether the code is correct, whether it satisfies all the requirements, for example, by your project, and whether you want to merge it and use that code. The process of a code review consists of the following steps or parts. First of all, it's writing comments towards the code. So you go over the changes, like we saw here. Here is a div. So you go over that div and write comments. For example, if you see a bug somewhere, or if you think this could be done better, or this could be speeded up, or this is there is a security hole, you write a comment about it. Then, after you have written all the comments, you give an evaluation. So you either approve the pull request, in which case it can be merged, or you request changes, in which case the author has to go over your comments and address all your remarks. And of course, the third step is discussing comments with the author. For example, you may have misunderstood something, or the author knows something what you don't know, and so you need to have a conversation with the author. Seldomly there are no discussions needed, everything is clear, but usually it's the case when there's a back and forth discussion between you as a reviewer and the author. So that's the process of a code review. This is a picture that I quite like. It's a code quality measurement, and it's based on the number of WTFs per minute. So if you have a good code, there's generally very few WTFs. But if you have bad code, the person who is reviewing it is always, what the hell, what is this? What? Oh, I can't believe that. So that's a bad code. So that's just for fun. But I think there's something there in this picture. So let's take a look at the reasons why you should create pull requests and do code reviews. What will they give you? So first and foremost, it's used for finding bugs or other defects, which most people associate with the term code reviews. The other defects can be, for example, performance issues. So if your code is underperforming, or there's a bottleneck or something, it might be found during the review. Another type of a defect is a security hole. So for example, in your code, you might have introduced a security hole which can make adversaries to abuse it, and for example use SQL injections or cross-site scripting to get data out of your systems or out of your users, which you don't want to. So a code review can help with that. Then another reason is that as a reviewer, you learn something new, or also as the author of the pull request, you can learn something new. For example, if you are reviewing code and the author used a library which you have no experience with and you don't know it, you can take a look at it and see whether you can incorporate it in your own code, see how it works in practice, or you can learn new language features, functionality from standard libraries, and so on. So both the author and the reviewer can learn from each other based on their comments or on the code. The third reason is getting familiar with code that is new. So if you are starting working on a project, people can assign pull requests to you, which are fairly, let's say, straightforward. But anyway, you need to familiarize with the code in order to be able to review it properly. So you need to take a look at it and see what you don't know. You can ask the author of the code, and generally you're getting familiar with the code. The fourth point, increasing pull code reviews and pull requests can increase the sense of mutual responsibility in your team. This facilitates collective code ownership, which is a practice from extreme programming. And basically what it means that both you as an author and the reviewer, you are both more responsible for the code. As the author, you have written it, but the code reviewer has approved it. So you should both make or ensure that the code is correct, and you are both responsible for the code. Another point is sometimes a code review may lead to finding a better solution. For example, if the reviewer is more experienced than you, they might suggest a different solution, which can lead to a decrease of the number of lines, or it can be more performant, or be more viable from the long run perspective, and generally it can be better. Another point, software tend to degrade over time when you do changes and refactorings and fix bugs. And code reviews and pull requests can slow down this process, as both you and the reviewer should ensure that the code is in good shape before it is merged. So in this way, your process can last, or your software can last longer and be easier to maintain over time. Some companies can have formal requirements on the development process. For example, airlines or medical companies can require a code review as part of the process or as part of quality assurance, QA. So in these cases, the code review can be mandatory, and you cannot merge any code without a code review, or maybe some other checks like static analysis and so on. But it can be a formal requirement in your company. Also, when having a pull request, you can run automated checks like tests, or whether all tests pass, or whether it is buildable on different platforms before the code is merged. So before you merge the commit and make it a part of the stable branch, you can run automated checks on it. And this also helps you to perform the code review process faster, as you will immediately see whether all tests pass or not. But generally, you can run these checks before the code is merged. Also, what is very important is that pull requests and code reviews are a way of contributing to open source projects, as you don't want to give strangers permissions to push into your repo. So how it usually works with open source projects, you have an upstream repo, which is yours, the project, and someone forks it to their personal space, then creates a branch, do the changes, push the branch, and create a pull request. And via the pull request, you can incorporate the changes from that another person's repository into your upstream repo. So this is how it generally works with open source projects. Then another reason is that pull requests and code reviews make it harder for adversaries. By adversaries, I mean malicious authors, to sneak malicious code into your project. So if you disable direct commits into master and everything has to go through a reviewed pull request, then it is much harder to incorporate malicious code into your projects, as there will always be someone who needs to take a look at the code and decide whether it is safe to merge. And last, but certainly not least, creating pull requests and doing code reviews lead generally to better code. I don't know how about you, but when I know that my code is going to be reviewed, I tend to pay more attention to it. And it was shown that this is generally the case, that people pay more attention towards code if they know that someone will take a look at that code. So these are all reasons for creating pull requests and code reviews. And really, I can tell you that pull requests and code reviews are vital practice in the software development world. So the talk is comprised of 3 parts. First, we'll take a look how to create pull requests. Then we'll see how to review pull requests. And last, we'll take a look at the discussion of comments. And I will give you several tips for each of these parts. But before we start, let me note that writing pull requests and doing code reviews is a skill, like any other skills, like cooking or programming, and you need practice to get better. So the more pull requests you create, the more code reviews you do, the more you are better at these 2 things. So this talk won't help you with the experience part. You need to actually create pull requests and do code reviews to get experience, but it can give you tips how you can improve your process and manage it like a pro. So let's first take a look on how to create pull requests. First of all, before opening a pull request, you should do a self-review. So you should go over your code and check whether you have committed everything, whether there are no typos or indentation bugs, and so on. The thing is that the reviewer is not responsible for your carelessness. So you should ensure that whatever you create and submit for a review, to the best of your knowledge, there are no issues in there. So what I suggest is to act as if there is not going to be any review, as if your code is going to straight into master or straight into production. So you should ensure that the code is really correct, and the reviewer is just to verify that everything is all right. What I like to show is this strip from a comics. Here is the author, and he says that no need to double check something. I'm sure that if there are any issues, the reviewer which will catch them. And then on the other side, we have the reviewer, and he says that, well, I don't need to take a close look at that. I'm sure that the author knows what he's doing. So always ensure that you take a close look on your pull request before you submit it. And if you are a reviewer and you are not sure whether you should go over something and so on, you should always talk to the author so you don't end up as these two here. Another tip, the more complicated the pull request is, the more detailed description you should provide. And I always suggest trying to put yourselves into the reviewer's shoes. So if you were reviewing the code, what would help you when you open it? What would make the process going faster, and what would make it more straightforward? So basically what you should do, you should describe what the pull request is trying to achieve and also why. The what part can be inferred from the code, but the why part is usually much harder to infer from the code itself. So you should include it into the description. So for example, this pull request implements XYZ because because some reasons which you give. Next, you should describe what were the major issues when creating or modifying the code, so that the reviewer sees what had to be considered whilst implementing the solution. Then, if there were issues, why did you decide to solve them in a particular way? And maybe there are some other options which you have considered, or there are some reasons why you have decided to go this direction, and so on. And you should describe that so the reviewer sees that you have considered all of that. If there are any problems to discuss, so for example, you were not sure how to do this or that, or there can be some performance issues in some cases and you would like to discuss that with the reviewer, you should also mention that. And you should also include any relevant tickets from your bug tracking system. So if the pull request fixes a bug number 1 to 3, you should mention that in the pull request, or that it improves the implementation of another pull request. You should also add a link to that pull request, so your pull requests and issues are interlinked. And it will simplify further investigations in the future. So if someone needs to know that there seems to be a bug in this pull request, why was it submitted, what does it solve, and try to get all the missing links. And if applicable, for example, when changing the user interface, it can be very helpful to include before and after screenshots. So the reviewer can easily see what's changed and how does it look. Here are two examples which I have chosen and would like to show to you. The first one is from the Rails repository. The content is not really of our interest now. I would like just to point out that there is a summary of what the pull request is trying to achieve. There are links to reference material. It also says that it fixes this issue. Then there is other information concerning the systems on which the author has tried to validate the pull request, and also there can be some other information. So this is the first one, and the second one is for this course, and this pull request adds support for local avatars, and it's a UI change. So here is a screenshot that you can use this button to change your avatar. Here's how what will pop up. And here is where you can see the avatar. And there are some technical details like what was needed to achieve all of that. So as a reviewer, you can read through that, and it will simplify the review. Now, if you don't take anything from my talk, what I would like you to remember is this slide, and I believe this is one of the most important pieces of advice in software development when working with version control systems, and that is to make so-called atomic commits. And a pull request, or in general everything you write, should be composed of these atomic commits. And an atomic commit revolves around a single topic and only this topic. So for example, it should fix a single bug, or should add a single piece of functionality, or it should be a pure refactoring, which means that it should only alter the structure of the code but not the observable behavior of what it does. Or the commit adds a new feature, or the commit changes the formatting of the file, and so on. So each commit should be dedicated to only one thing. So as I have said, you should separate these steps into separate commits. The rationale for this is that, for example, let's say that you reformat the whole file and then add a bug fix there. And as a reviewer, if you only see this commit, this diff, you are totally lost, as you are unsure which changes are just part of the reformatting and which change is the actual bug fix, which can be crucial to get right. But if you have these two changes into separate commits, the reviewer can easily see that this one is just for reformatting, and this one they should focus on because that's the one for the bug fix. And in general, atomic commits are easy to reason about. So you just see that commit, it does reformatting, that's straightforward. They are easier to review. So the reviewer can go through the commits one by one and review each one separately, as each commit describes what it does. And if it is atomic, then it's much easier to focus just only on a single change at the time. So it really helps me as a reviewer and other people to review the code. Atomic commits are also easier to revert. So for example, if you find out that the bug fix that you did does not work, we can revert it. But if it is part of a larger commit, you may want to keep the rest of the changes, but only revert the bug fix. But that's much harder to do when there are additional changes in the code, as you cannot simply use git revert and the hash of the commit. And finally, atomic commits might make git bisect work better. If you are unfamiliar with git bisect, it is a subcommand that allows you to determine which commit, for example, broke the build or introduced an issue. And Git will automatically go through your commits via bisecting it always into two parts, and which is faster than going over each commit one by one. So this only works if you have atomic commits. If you stumble upon a commit that changes 100 files, then you need to go over all these 100 changes to see which one of them broke your code. So how to do them? First of all, you have to commit diligently or prudently. So really focus on what you are committing and whether these two changes that you are committing really belong together. Second, you can use so-called Git's patch mode to incorporate only what you need into the commit. So here you can read all about it. You are mostly familiar with that git add -p, which allows you to stage only part of your changes. So if you do two changes in a file, you can use git add -p to only stage some of them and commit them. So this facilitates atomic commits. There are also some other uses for the patch mode with committing, with resetting, checkouting, stashing, and with git log. So you can read all about it on my blog. Second very useful tool is interactive rebasing, which allows you to make commits and then decide that, well, this commit and this commit should be one commit, so you can put them together, or you can split a commit into two parts. So basically you can rewrite history on your branch. With the usual caveats that rewriting history is only safe in particular situations, like when you are working on your local branch that nobody has based their work on. which is usually the case when you are creating a pull request on your own branch. Now there are some smells that you can utilize to find out that you are not really making atomic commits. The first of them is when you have a tendency or an urge to put an AND conjunction into a commit message. So if you are writing something like this commit fixes X and Y, well, then it's usually not an atomic commit, and you may have to split them into two commits. And the other smell is if you say to yourself, well, screw it, nobody will notice. Well, people will notice, and you shouldn't screw it. Just create atomic commits. Don't be lazy, please. Another advice is you shouldn't be afraid to leave comments by yourself. Basically, whenever you don't understand something or you would like to discuss something with the reviewer, you should leave a comment. Don't wait on the reviewer to find it on their part, as it wastes their time. If you know that you need to discuss something or something doesn't work, it is your duty to report it in order for the reviewer to not waste any time. Another tip is that larger changes or huge PRs should preferably be pre-approved by the maintainers of the project. This is to minimize the risk that your changes will not be accepted. So before opening a huge pull request or doing some controversial change, you should always talk to the maintainers, either by creating an issue or on IRC or any other communication channels that the maintainers use, and discuss your change. And they might tell you point blank that they don't want that, or it won't be merged, or tell you that yeah, we would really appreciate that and this is the right way to go, so you can go ahead and create a pull request and we'll take a look at the pull request. And also, when as an author you are in doubt, you should ask for what I call a concept review. I don't know if that's an official term, but I call it that way. What it means that you can create a pull request with only part of the changes, so the reviewer can take a look at the changes and see whether this way is the way we would like to go. And if not, they can suggest a different route or talk to the author and come with the best solution. So this is a, let's say, half-baked pull request, for example, with no tests, and there can be many formatting errors and so on. But this is just to verify that your changes are all right from a conceptual viewpoint. Now, if you receive a comment from the reviewer, it should always make you think, why have I not thought about that, right? What can I do to improve my code in the future so I don't receive these comments? Because if you receive a comment and say to yourself, well, they have found out, that's bad, that's bad. I was afraid that they would find out. Then you are just wasting people's time, reviewers' time. So every comment from a reviewer should make you think, why have I not thought about that myself? And try to really step up and try to create as great pull requests as possible, and try to learn from every code review. Another point which relates to those atomic commits, which we have already discussed, is that in a single pull request, you should generally include only related changes. So if your pull request fixes a bug, that pull request should only fix that bug. It shouldn't include irrelevant fixes of typos in other parts of the code or formatting issues and so on. So what I prefer doing is either fixing those typos, formatting stuff and so on directly in master, or opening another pull request. So generally, do not solve multiple issues in the same pull request. There are also other reasons why you shouldn't do that. For example, it's harder to parallelize review of a huge pull request if there are multiple unrelated changes. So if you put those changes into separate pull requests, there may be multiple reviewers to review each of the changes, which will speed up the review process. And also, if some of the changes are minor and can be reviewed by a less experienced person, you can just give them the minor parts and let the big part be reviewed by an experienced developer in your team. If you only create a single pull request, then this is off the table, as for example, the beginner or the junior developer would be lost in all those changes. And also, when reviewing a pull request, I can tell you that it's much easier to review it if it is only focused on one thing. If not, you can wonder, well, why is this change here? How is it related to the other parts? I'm not sure. I should take a look. And this is another situation where you waste the reviewer's time. And well, you have to accept the fact that not all pull requests will get merged. And that's the weight of life, c'est la vie, as the French say. Well, you just have to live with that not all your pull requests are going to be merged, and this is fine. Sometimes you find that this is a dead end, or that there is a better way, or someone has already beaten you to it and did the changes faster, and so on. So don't be mad, don't be disappointed, just learn from that experience and move on. So now that we have seen how to create a pull request, let's see how to review one. I will show you 4 slides with 4 priorities on what you should focus on as a reviewer. And you should always review code with focusing on these priorities in order. So if there is something wrong with priority number 1 and it is something major, then sometimes you don't even need to continue, and this has to be fixed before you should do that. As otherwise, you may point out several comments towards the code, but the code will have to change anyway, so that would be useless. So priority number 1, does the code do what it should? Nothing is missing. And doesn't it do something it should not do? And additionally, does the project function correctly? So it provides everything that it is supposed to provide. And do all the tests pass? You can use continuous integration for that. We'll take a brief look at it at the end of the talk. So if you have continuous integration, you can use that. Otherwise, you will have to run the tests by yourself. Also, you should check whether there are tests for the new code or changed code, as if there are no tests, the code cannot be trusted, and I say that it doesn't work if it is not tested. So you should verify that. Also, you should check whether the documentation has been updated, as there are only few things worse than looking at a documentation which says something, but the code behaves in a different way, which wastes your time. And you should also think about backward compatibility. For example, when doing versioning, like whether you should increase the major version, minor or patch part of the version, Or if you provide an API, an application interface, you should check whether the change doesn't break it and whether it is possible to do it with the current version of the API, or whether you need to bump the version of the API. So you should also check that. Second priority, you should check whether the code is safe. What I mean by that is that first, are all errors correctly handled? So if a function returns a null pointer or none, will this be correctly handled? Or what if the user passes an invalid number into your program? Is it correctly handled? Or if, for example, if there is a connection error, a timeout from an HTTP 8 point, or a database error like a failed constraint, will the code recover from that? And are all these errors correctly handled? Also, you should verify if the program is, let's say, impossible or very unlikely to crash, as it is often very hard to really verify that the program cannot crash at any circumstance. So you should just take a look at it and see whether there are no obvious ways that the program can crash. Number 3, is the code free of security flaws? So, for example, is it impossible for users to utilize SQL injection or cross-site scripting or path traversal to get user data? And you need to be familiar with the types of security flaws in order to be able to see if the code is or is not vulnerable to any of them. So practice makes perfect in this case. If you are running multi-threaded code, you should verify that the code is thread safe. So for example, if there is no possibility of two threads modifying the same variable at once, if you are using logs, semaphores, monitors, and so on, if you are using them correctly, or whether there is a possibility of a deadlock and other synchronization issues. If you are connecting, for example, to databases or opening files or communicating via network, you should check whether there are no resource leaks. So if you always close open files, so you don't leak file descriptors, open file descriptors. If you don't leak memory, which can have very bad consequences if your application is a service running on a server. And also you should check for other resources. Pretty much everything you use, there should be no leaks. Otherwise, your risk that your resources will reach the limit, like the number of processes, total amount of memory, maximal number of file descriptors, and so on. So that's number 2, whether the code is safe. In number 3, in priority number 3, we'll check whether the code is readable, maintainable, and whether it is not needlessly inefficient. So you should check whether the change fits into the code or into the project, or whether it was hacked there, like using the shotgun surgery anti-pattern, which means that the person who did the pull request opened the project wide, did changes to 100 files without thinking about the change, and just did dirty work. So you should ensure that the code, if it does what it is supposed to do, whether it fits into the project and whether it won't cause any maintenance issues down the road. Next, languages usually have idiomatic ways of writing something. So for example, in Python, code can be Pythonic or unPythonic. So you should verify whether the code is idiomatic, or whether there is an established way of writing something which is much easier to read, or which makes it much easier to read and reason about. If you know about a library that you could use instead of manually written code, it can be beneficial, as the library may be a widely used one, which is properly tested. So for example, when working with Unicode or decimal numbers and regular expressions, usually you should use an existing library instead of writing your own one, which you would need to test. You will need to gain expertise in that area, and generally the code will be much more prone to error than using an existing library. Of course, your mileage may vary, but usually what you should at least check is that whether there is a library or a package that you could use that would make your life easier. And you should also check whether there is no duplication. What I mean by that is there can be code duplication if someone just use Ctrl+C and Ctrl+P, or there can be structural duplication in the form of violating the law of Demeter or Demeter. I'm not sure how to pronounce it properly. Or there can be knowledge duplications, and there are various types of duplications. As a reviewer, you have a very hard time here, as if you are only looking at the diff, you may not see that there is a duplication if the code was copy-pasted from a place that wasn't changed. So you should be familiar with the code base, and if you see a code in a diff that you think that you have seen somewhere else, you should check it, and if there is a duplication, you should point it out, as duplication leads to all sorts of issues down the road. And also check if there are no useless parts of the code that unnecessarily slow it down. So if something can be written more efficiently without sacrificing readability, you should go for that. And last but certainly not least, check whether the implementation is not over-engineered. Whether it's the proper way of, for example, fixing the bug, or whether the author has needed to devise or create, 10 modules just to fix a simple bug, which can be fixed in a much simpler way. So tend to go with simpler solutions and not the over-engineered ones. So that's priority number 3, whether the code is readable and maintainable. Number 4, that's the last priority, and in there you should check whether the code conforms to coding conventions. So the usual suspects are here, like spaces versus tabs, whether there is no useless trailing whitespace, which makes people's lives miserable. Check the naming of variables, whether you use snake case, camel case, or any other casing. Code formatting in general, so if curly braces are properly placed, there's a proper indentation, light wrapping, and so on. Unless you have a linter, or unless you use a code formatter, which I really like, as it makes it easier to check whether the code conforms to the coding conventions. If you use the same code formatter, you can just perform or create the pull request, run the formatting tool on it, and ensure that everything is properly formatted. And you should also check if there are some typos in grammar or grammar issues in strings or comments. But this is the lowest priority. So if there are bigger fish to fry, you should focus on that and focus on these things only as the last part of your review process. Now, when reviewing code, you should generally be respectful, so you should not insult the person or insult their intelligence and so on. But if there is an issue with the code, you should report it. So if you think that you shouldn't report an issue because John might get upset, well, that's his problem, that he shouldn't get upset over his code. But it's the way that you write your comments that matter. So you should always focus on the code and report what you have found. And if you found a bug, it is your duty to report it, but of course in a respectful way. So be respectful but brutally honest when doing reviews. This slide relates to the previous one, and remember that you are reviewing the code, not the person. So please, let's not get personal. And it should be the code who is under review, not the person. So do not write comments like, well, John, you always write stupid code, or think that John is stupid or so on. Just focus on the code and review whether the code is correct, not whether you like or dislike John. Also, it is very important to make useful comments and generally leave the useless ones at home. As when the author sees your comments, they will need to act on them. They will have to read them, understand them, and discuss them with you. And if they are useless, then, well, what the author is supposed to do with a useless comment. So when pointing out a bug or an issue, you should always add a reason why. So if you think there is a better way, you should describe why is this a better way. Or if you think there is a bug, you should explain why do you think there is a bug. What is important that if you criticize something, please include an alternative way that the author should consider. Otherwise, it is just mindless bashing. So don't just write, well, I don't like that, but I don't think what else to do with that. Because if the author reads that, well, what is he supposed to do that? He should have already written the code to the best of their abilities. So that's just plain useless. Also, it is useful to include links to supportive material like articles or talks. So if you see an SQL injection vulnerability, instead of writing an essay on what it is, how it works, what you should do to fix that, just link them or add a link to an article which describes the issue, and the author will read it, will understand it, and will fix it. And a pro tip, if there is no such article, no such blog post, create your own one, which is what I like to do. So for example, if I see some issue for the second time, I try to search whether there is an article on it, and if not, I write it myself. So the next time I see the issue, I can just link the author, the article. If you don't understand something, please ask the author, because it can mean that there is a bug or that the code is not self-explanatory enough and needs to be improved. So if you don't understand something, don't hesitate and just state it in a comment. Hey John, I'm not sure if I understand this piece of code. Does it work like this or like that? Or could you please include a comment describing why this has to be done in this way or so? And don't be ashamed of not understanding something. We are all human. We all make errors, and there actually might be an error in the code. So don't pretend to be a know-it-all and just ask. Also, sometimes it is useful to ask questions that make the author think, like, what happens if this function returns a null pointer? And the author will take a look at it and say, yeah, really, there is no check and it can crash. So yeah, I should fix that and also add a test that will ensure that the code is behaving properly. Another important point, if you see an issue with the code, like it crashed on your PC, you should describe steps to reproduce. So everything you have done in order to reproduce the reported issue. Then you should describe what is the expected behavior and the actual behavior that you have seen. So for example, let's say that I have opened this page, then I have clicked on button A and it took me to page C. But instead, I expected to be taken to page D. And the author can take a look at that, and either there is really an issue, and you are right, or this may be a feature, or this may be in the specification, and you have just misunderstood how the application should behave. So when reporting issues, it is important to include all these three parts: how to reproduce the issue, what is the expected behavior, and what behavior you have actually seen. And now a pro tip. Sometimes it can be useful to report an issue by crafting a failing test. As if you have a test, then you have the steps to reproduce, you have the expected behavior in the form of assertions, and the actual behavior is that the assertion do not pass. And the author can take a look at the code, fix it, and include the test into the test suite. So it's a win-win situation. Also, what I suggest is to show appreciation when reviewing the code. But remember that the appreciation has to be honest and has to be specific. Otherwise, if you include just generic appreciation like, you're the best, you create the best code and so on, well, nobody will buy that and it will sound insincere from your part. So try to be honest and really specific. Here are some examples. So for example, if the author has used this util str2bool function from the standard Python's library, which is used to convert strings like one or on, off into bool, and you didn't know about that, you can just give them a thumbs up that, well, I didn't know about that. Cool. That's a very good way of converting the strings. So nice. Or if the author had to go through some referential parallel code, you can clap them and say that thank you for analyzing the parallel code. I know it must have been really hard. Or if you have written that, there was a spurious test fail, or the author, then you can tell them that, I have learned a new word today, spuriously, so thanks for that. So show an appreciation. We are all humans, and we enjoy being appreciated. So we know that our work has its merits. Then when reviewing a pull request, I suggest to always leave a comment. So it can be plain and simple, just it looks good to me and a thumbs up, but include a comment. Otherwise, it may feel as if nobody bothered to go through the code, or it may mean that if you see a pull request, you immediately click merge or approve. So please write a comment. And sometimes you can even write just LGTM as an abbreviation of looks good to me, or include a cute picture or whatever floats your boat. But please write something to the author. Another tip, you should pay close attention to how you write sentences in your review. So for example, you should use I suggest or consider for non-critical issues, which may be really subjective. And in this way, you are telling the author that you are offering this piece of advice only for suggestion, and it will be fine if the code is not changed. So you are just offering advice that they should consider, and you should explain why they should consider your advice. To facilitate collective code ownership, I suggest using we instead of I and you, as we are both developers and both work on the same code, so it is our code, and we should do our best to create the best code. So it shouldn't be I, you, he, him, but it should be we. We are working on the code, we are maintaining it, we are reviewing it. It is our code. And if you see a nitpick, like a typo or a grammar error, I tend to prefix them with the word nitpick, so the author sees that, well, this is just a minor thing, and they can fix all of the nitpicks at once. And distinguish the more important comments from unimportant ones, like nitpicks. So mind the wording that you use. Also, this may be obvious, but I would like to state it anyway. One pull request can be reviewed by multiple people. And if you are changing a critical part of the code, then I suggest that at least 2 people take a look at it in order to be sure that the code works as is expected. And in some business areas, it may be even required for multiple people to take a look at every change. So multiple people can review pull requests. Another tip, you should always finish the review in a timely manner. And generally, do not wait a month or more to do the review, as it discourages the author from providing pull requests in the future, or from considering your project for contribution in the future. And if you stop if you pause during the review process, both parties, the author and the reviewer, will need to refresh their memory when starting to work or continuing working on something. So try to do the review in a timely manner. And here is an example of how not to do it. So there is a pull request that adds support for the coverage package greater than 501 or 5.1. And as you can see, the pull request has received several thumbs up, and there are also other people who are waiting for that piece of functionality. And it was submitted on the 3rd of January. And then if you read through the comments, there's from February 28 or March 5, bump. This person couldn't take it any longer, so they tagged all the maintainers from the company. And finally, someone after 3 months or so says that, well, thanks, I will review it shortly. Well, then there's no review, and after 9 days, someone says that, could you add test for this solution? Well, okay. Then according to the JetBrains policy, you need to submit a contributor license agreement. So, well, all right, the author did that. And finally, after about 4 months, the code got merged. But this is really discouraging, and must have been discouraging for the author. So please, if you are a maintainer and someone submits you a pull request, either do the review in a timely manner or write that you are currently unable to review it, so the author and other people who depend on that pull request know that you will get back to it later. But without any reaction, it's really strange and discouraging. Now to close the part, let's take a look at some anti-patterns when doing code reviews. The first anti-patterns is focusing primarily on nitpicks. So if you have code, you should generally go through the priorities as I have advised, priority number 1 and through priority number 4, and focus on the most important things, which is finding bugs and defects, ensuring that everything works, that there are no errors, security issues, and so on. So don't focus on nitpicks, focus on what's supposed to be done when reviewing code. Another nitpick is forcing subjective changes upon the author. So if the code is correct and there is nothing wrong with it, but you would like it to be rewritten in a certain way, you can offer it as an advice and describe why you think this is better, but you should never force subjective changes, as it feels like that you are commanding the author, which should not be the case. Another anti-pattern, if you have external contributors, so if you maintain an open source project, then sometimes if you see nitpicks there, it may be useful to thank the contributor for the contribution, manage the code, and fix the issues by yourself. So this is what I like. If the contribution is otherwise sound, then I see no reason for forcing them to fix nitpicks. Another thing is inconsistent feedback. If you write a comment that it is generally better to do this and this and that, and several comments down the road you say that the complete opposite, the author will get mixed feedback and wouldn't know whether they should do this or do that. So try to be as consistent as possible. Another anti-pattern is called bike shedding, or Parkinson's law, or the law of triviality, which states that people give unproportionate weight to trivial issues when doing something. And as example, if you are building a nuclear power plant, there are some issues that you should be really focused on. For example, where you will store the waste, how will you deal with radioactive materials, and so on. But as it was shown, most people focus on really trivial things like what should be the color of a bike shed, where you store your bike. And that's really unimportant, but everybody has an opinion on the color or material for the bike shed. So that's easy to discuss, but there shouldn't be much weight put into those trivial issues. So if you see bike shedding, just write that we are bike shedding. Let's settle on one solution and move on to better things to discuss. Another anti-pattern is so-called back and forth reviews, also known as ping-pong reviews. When you write a comment, then the author fixed that, you write another comment, the author fixed that, and so on. And it wastes time. So try to write all your comments, and for the author, you should try to fix all of them and try to make the review process as short as possible and as focused as possible to find bugs, defects, and the other things which matter. And last anti-pattern is when you are doing the review and you don't see anything wrong that you would need to bother the author, or let's say it in this way. If you both work at the same office, you shouldn't go to the author with every comment that you have found and discuss it with them. It's really bothering for the author. Unless this is a major issue that you need to discuss with the author, otherwise it is impossible for you to finish the review. But if these are just regular comments, you should just write them down and let the author have the time to take a look at them, and then you can maybe discuss it. But do not bother the author constantly during the review process. And finally, there is a funny tweet which I like, and that says that if you have 10 lines of code, well, you usually find 10 issues with that. But if you are reviewing pull request with 500 lines of code, looks fine, looks good to me. So that's the truth behind. Unfortunately, that's the truth behind some pull requests and some code reviews. All right, let's move to discussion of commands. First of all, it's nice to show appreciation, that you appreciate someone took the time to do the review or give you their opinion, their advice, their suggestions. So here's a couple of ways you can show appreciation. For example, if someone raises a good point, you can say that, well, that's a very good point, or a great point, or nice catch. If someone catches a bug that you've done, or if someone suggests a language feature, library function or so, you can say, well, yeah, I didn't know about that. Thank you for the tip. Or if you propose an alternative that is better, or if the reviewer has proposed an alternative that is better than your version, you can say, well, the proposed alternative is indeed better, let's use it. As I have already mentioned, you shouldn't take comments personally, because it should be the code that is being under review, not you. So again, if you made a mistake, you have to deal with it. Don't be angry at the reviewer, don't be angry at yourself. Try to learn from it and try to not repeat the same mistake twice in future pull requests. Once again, code review should be a discussion. It shouldn't be a list of commands from the reviewer that you are obliged to perform. So if you disagree with something, let the reviewer know and let's discuss it. But please bear in mind, if you disagree, you will have to explain why you disagree. For example, because there is a reason that the reviewer's solution might not work, or it might not perform as well as your solution, or it might be less readable or harder to read, and so on. So it's important to describe why. And please let the reason not be, screw it, I'm too lazy to do that. You know, like Garfield, I can, but I won't. So don't be lazy. And here's a nice example. It's not a pull request, it's an issue, but I think it's funny and worth mentioning. So here's an issue that a user had troubles uploading something to test PyPy. That's irrelevant, but after 2 weeks, they decided to close the issue, and someone asked, were you able to resolve the issue? And they said, no, I decided I don't care. So I think you should care. And yeah, that's that. That's my piece of advice. If you are not sure that you are able to perform the review, for example, if the reviewed part you have never seen it and it's beyond your current experience, you may tag or invite other people and ask for their opinion. Ask them to help you with the few lines of code that, for example, you don't understand and that they have written, or that you can ask them to do the review instead of you, as they have more expertise in that area, and so on. So in general, don't be afraid to ask for help, or even you can even ask for help the author. If you don't understand something, maybe they can explain it to you. So don't be afraid to ask for help. I generally recommend reacting to all comments and marking the discussions as resolved, as if someone stumbles upon your pull request in the future, for example, if they found a bug in the code, they may want to know why you have done something, and so they open the pull request, see the discussions, and for example, there may be a discussion concerning the bug, but without the resolution, which is very strange, and you would feel hopeless if you looked at the pull request. So I suggest reacting to all comments and explain how each of the issues were resolved. So for example, if you talk to the author in person and you agreed to something, you should mention it in the pull request. We have discussed it with the author and decided to go this way. So if anyone else is watching the pull request and the discussion, they will know why you have decided to go and which way. However, for trivial issues like nitpicks, typos, cosmetic fixes, it's enough to mark the discussion as resolved. No need to write anything, as it is obvious what has been done there. Well, we have almost reached the end, so let's conclude the talk. As our time in this talk was limited, we have skipped several things that you might want to look at. So here's an incomplete list of what we have skipped. So for example, we haven't discussed how to select the person who should review the pull request, as there may be multiple people in your team, or how you should review a large pull request containing a lot of changes, like 50 commits and 100 changed files. I hope there is no pull request with 100,000 changed files. That would be a pain to review. We also haven't discussed specifics of various systems that you might use for pull requests or code reviews, like GitHub, GitLab, Bitbucket, Gerrit, and other. There are many such systems. We have touched the topic of continuous integration, which you can set up for your pull requests, and it can, for example, check that the formatting is correct, run linting, run the build, run tests, and report it back to the pull request. So as a reviewer, you can see that all the tests pass and so on. So your job will be a bit easier. There is also a possibility to add hooks to pull requests. So for example, when someone opens a pull request, you can get a notification, like on a Slack channel or Mattermost or whatever communication system that you use. Or you can create bots that will, for example, ensure that everything is included in the pull request, or assign it to the person who should review it automatically, or close pull requests that had no activity for several months. And the possibilities are pretty much endless. And there is also the topic of licensing and contributor license agreements, CLAs for short. These can be used to enable companies to easily pursue legal resolution in the case of copyright disputes and protect them from, for example, from patent disputes and so on. And I don't want to go into that in this talk. So feel free to check these items out after the talk. Here is some recommended reading. Some of the books are dated, maybe, but I really enjoy them and I can recommend them to anybody who wants to be not only a better programmer, but to write higher quality code, which is what this talk is about, writing high quality code by creating pull requests and doing code reviews. As this is a Czech talk for Czech audience, I have also included translation of some of these books into Czech. A bit of harmless self-promotion, which hasn't hurt anybody. Here are links to some of my talks on my Czech blog, because this is a talk for a Czech audience, so you can read them if you enjoyed the title or if you enjoyed my talk. The only English post related to this talk is this one on Avast's blog. On Avast's blog. Which you can read and contains the things we have talked about. All right, so let's summarize what we have learned in today's talk. We should strive to use workflows that utilize pull requests and code reviews because of the many benefits that they provide. I went through several of them. They lead to cleaner code, finding bugs and other defects. So the sooner you find the bugs, the better, because if you find the bug in production, it's much more costly to fix it than when you find it during code review. And it's the way how open source projects work and so on. Writing pull requests and performing code reviews is a skill like any other action that you may repeatedly do and be better at it. So the more pull requests you create, the better you get, and the more code reviews you do, the better you generally get. But you have to learn and try to be a better author and a better reviewer, and strive to really do your best. Before submitting a pull request, you should do a self-review to help the reviewer focus on their job, and they shouldn't be bothered by your carelessness. So you should care before submitting a pull request that it is in a good shape. You should try to put yourself into reviewer's shoes. So try to make the pull request as reviewable as possible by creating or crafting great pull request description, and by creating atomic commits and atomic pull requests, which revolve only around a single topic, like fixing a bug or refactoring or adding a new piece of functionality. If you receive a comment from the reviewer, every comment should make you think and try to step your game up and be better next time. Think about why you haven't thought about what you have read in the comment. When reviewing code, it is generally best to focus on the most important things first. So we have seen that, at least from my perspective, the fact whether the pull request does what it is supposed to do is the most important thing. Then whether it contains any errors or whether it is safe. then whether the code is maintainable, readable, and generally fits into the project, and last but certainly not least, or whether the code follows coding conventions of that particular project. Also, both as a reviewer and as an author, try to make only useful and informative comments so the other party can learn something from them, and leave the useless comments at home, because why you should care about a useless comment. Also, we should focus on the code and leave personal issue behind. So even if you might not like John, you should review just his code and leave personal issues behind. And it is good to show honest appreciation, that you appreciate the other side and that they took the time to either create the pull request or review it. And don't be afraid to disagree. The review process should be a two-way communication. It shouldn't be a list of commands from the reviewer from the position of an authority. You really should be able to discuss it. Well, the goal is to have as good code as possible. So yeah, that's it. So that's the summary of my talk. Thanks everyone who have watched the pre-recording. And if you have any questions towards what we've been through, either leave a comment below the video or write me an email and I'll try to answer it. So see you next time. Goodbye.